Wednesday. And so I will pass out not only your homework today, but the review early so you can get started on it, okay? Because, of course, it's muy importante that you get that review done. So today we are doing more triangle proofs. And what we have today is proving triangles congruent. And once we have congruent triangles, then we can say, oh, and then this other thing must also be congruent, okay? So this is Cpctc, and Cpctc stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So if we have congruent triangles, then I can pick a pair of sides, or I can pick a pair of angles and say that those are also congruent. Because if the triangles are congruent, then we know that there's three pairs of sides and 3 pairs of angles that are also congruent, okay? And so use Cpctc when asked to prove parts are congruent. And by parts, we mean any sides or angles. But first, and this is a really important part, but first, you must prove the triangles are congruent. And so what we're doing is basically proving triangles congruent first, and then proving the extra parts are also congruent. And so it's really important that we look to see, hey, what are we trying to prove congruent, and what triangles must we prove congruent first, okay? So here in this question number 1 here, proof number 1, we want to prove angle BCA. That's this angle right here. I'm going to put a little red dot right there. That's that little angle BCA is congruent to DCA, the little angle below. So we are trying to prove those congruent, which really means that we're going to have to prove we have this top triangle and the bottom triangle. So we need to prove those 2 triangles congruent first, and then we can say, oh, if those green triangles are congruent, then those red angles must be congruent by Cpctc. Okay? So let's start with, as always, the givens. So segment AB is congruent to segment AD. That is given. What do I do when I write something down in my statements and reasons? Mark it up on my picture. AB, segment AB is congruent to segment AD. And when I look at those, that is a pair of sides. Yeah, I got a pair of sides there. That is congruent. All right, let's see. We also know that segment BC is congruent to segment DC. That has also been given to us. And then again, I also am going to mark it up. BC is congruent to DC. And again, I'm using a different set of markings because they're a different set of sides, right? So again, that is another pair of sides. Ladies and gentlemen, look at those green triangles. Tell me what else you know from this picture.
Reflective.
Yes, we have a reflexive side. Segment AC is congruent to segment AC by the reflexive property. They are sharing a side. So that is a third side. What do we know now? The triangles are congruent. So here's where we have to be very careful. Triangle something is congruent to triangle something by the side theorem, but we have to name these triangles the proper way. So if I look at my top triangle and I'm going to go ABC, so triangle ABC is going to be congruent to triangle what? Yep, ADC. So I went 1 tick mark, 2 tick mark. So I got to do the same pattern on the lower triangle. 1 tick mark, 2 tick marks. So ADC. All right. Very important that you get those in a correct order. Now there are like 6 ways to write those congruent statements. So you just got to make sure you get a match. Okay. All right. Now that the triangles are congruent, now we can say that, oh, those little angles that they wanted us to prove must also be. So angle BCA is congruent to angle DCA by CPCTC. Congruent parts of congruent triangles are congruent. CPCTC. CPCTC. Yep. All right, let's look at number 2. On number 2, they're telling us that PS is parallel to segment QR, given. And of course, then I need to mark it on my picture. PS, my little triangles, and QR are parallel. Lots of things we need to look out for when we have parallel lines. So that's the first statement that's given, and then I'm also going to go ahead and do the second one here. Angle QPS is congruent to angle SRQ. Let's see, QPS is this angle right here. P is in the middle. All right, QPS. So this angle here is congruent to angle SRQ. This angle R is in the middle. So SRQ is this angle over here. That has also been given. So we have a pair of angles that are congruent right off the bat. Now, they gave me parallel lines. So what do we know when we have, let's see, a parallel line and another parallel line? The Z shape, yeah? So parallel line. Then I have this Z that connects them, and that Z shape is code for what? Alternate interior angles. Yeah, which would be this little angles right there. So how do you name that angle? Nope. PSQ. S is the vertex of the angle, so S must be in the middle. So PSQ, angle PSQ would be a great way to name that angle. How do we name this other angle at the bottom? RQS. Angle RQS. Very good. Again, the vertex of the angle is at Q. Q must be in the middle. All right. Really important that you get those named right. If they're named wrong, your proof is completely invalid. Okay. So, got to be careful. So, what's our reason here? If parallel. Again, they gave us parallel lines, so we're going to use that in our reasons. If parallel, what's the name of these angles? Alternate interior. Yes, alternate interior angles are congruent. All right, and then that's another pair of angles. And then what else do you know from this picture? Reflexive, yeah, QS. Segment QS is congruent to segment QS. It is in both triangles. It is a reflexive side because it's part of both. All right, so that is a pair of sides in both triangles. So what do we know? Angle, angle, side. The triangles are congruent by angle, angle, side, angle, angle, side, angle, angle, side. Okay, and that is a proof. That is one of our triangle proof theorems. Okay, so we have some congruent triangles. Triangle what? PSQ. Okay, triangle PSQ is congruent to triangle? No. PSQ RQS will work. Triangle RQS. So again, you have to go in the same order. We went, whatever color, maroon, pink, and then the third angle. So we have to do the same thing, maroon, pink, and then the third angle. So RQS, they have to match. All right? All right, so then if those triangles are congruent, let's look. PQ is this segment right here, and RS is this segment right here. Are they going to be congruent? Yeah, they are. So segment PQ is congruent to segment RS by what reasoning? CPCTC. CPCTC. Congruent parts of congruent triangles are congruent. All right, questions so far? Good, all right. Cool. Oh, look, it's the last page, you guys. Wow. Crazy. I think I kind of want to go to 4 and 5, and we'll do those. Okay, so 4 and 5. All right, let's see. JM, segment JM bisects angle KJL. That is given to us. Once I write it down, what do I need to do? Mark it on my picture. And really understand what it's talking about. Segment JM is bisecting angle KJL. So JM is right here, and it's bisecting this large angle into what? Two congruent angles. Yeah, these the little upper and lower little angles have to be congruent. Can I do that next? Can I maybe write that down? Yeah. Absolutely. So I'm just going to go ahead and say, hey, angle, how do I name this top angle? KJM. Must have 3 letters. KJM. Angle KJM is congruent to angle LJM. Why? If angle bisector, then 2 congruent angles. Yes, if we have an angle bisector, then we have 2 congruent angles. And again, we know it's an angle bisector because they told us right here it bisects an angle. And so we're using that in our reason. If we're given an angle bisector, then I know, and then another piece of information. Okay? All right, let's see what else we've got going on here. The next thing we know here, oh, I should mark that on my picture. Here are these little angles. We got a pair of angles congruent. All right, great. Next is another given statement. Angle JMK is congruent to angle JML. All right, that was also given to us. And again, I need to mark up my picture. So JMK. Where is the vertex of this angle? At M. JMK. That is this top wide obtuse angle, and JML is the one below it. That's these big angles right here. Another pair of angles been given to us. What else do we know, ladies and gentlemen? Well, reflexive side, yes. Right here in the middle, JM, segment JM is congruent to segment JM by the reflexive property. It is a part of both of those triangles. So what do we know? That is a pair of sides there. Angle, side, angle. All right, so we've got some triangles that are congruent by angle, side, angle. Let's see. If I say, I'm going to, now pay attention here, triangle KJM is congruent to triangle what? Good. KJM went nothing, maroon, and green. So we want to do the same thing on the other triangle. Nothing, maroon, and green. So that would be LJM by angle, side, angle. And then, of course, the last thing here, now that we know that those top and bottom triangles are congruent, then we're proving that JK is congruent to JL, which must be true. So JK is congruent to JL by Cpctc, yes. All right. Good so far? Yeah. All right. Wow. Last one, number 5. All right, right off the bat. Actually, first, I really should start with what I'm trying to prove. ED is a side. We're trying to prove it congruent to CD. So those two sides we're trying to prove congruent, and of course, they're part of the top triangle and the bottom triangle. So I need to prove those two triangles congruent first. So I'm going to start with BC is parallel to EF. That was given to us. Segment BC is parallel to segment EF. All right. What do I know if I have some parallel lines, ladies and gentlemen? C, BCE, and so we have parallel lines, which means we got the Z shape. Yes, we do. There's definitely a Z shape here. All right. So I have this Z shape, which means I have this angle here at angle C and angle E that are alternate interior angles. But again, I want to be very specific. So angle BCD is congruent to angle FED. Yes, angle FED by what reasoning?
Or if parallel lines.
If parallel, alternate interior angles are congruent. Beautiful. All right, that is a pair of angles that are congruent. Let's see, we also had another given statement. So right here, D is the midpoint of segment BF. That is given to us. Let's see, D is the midpoint. So D is the midpoint of this segment BF. And again, I like to mark very clearly what I'm thinking on my picture. So again, D is a midpoint of the green segment here. What does that mean if I have D is the midpoint?
So segment BD is congruent to segment BF.
Yes. All right. So segment BD is congruent to segment DF because why? If midpoint. Yes. If midpoint, we get two congruent, I'm going to say segments. If midpoint, we get two congruent segments. So here we have a pair of sides. All right, what else is on our picture? What else is in this picture? Vertical angles. Very good. Right here, we have a pair of vertical angles. Vertical angles are congruent. Let's see, I'm going to call that BDC. Angle BDC. BDC is congruent to what angle, Cash?
What was it? Oh, it would be EDF.
Nope.
Or wait. Oh, it's the other way. The FDE.
FDE would be correct. FDE. All right. So there we have another pair of angles that are congruent. So what do we have here?
Angle
Is it angle side angle?
No. Or is it just angle side? Yeah, it's angle side angle.
It's angle angle side.
Angle side.
It's angle, then an angle, then a side.
Oh, I was going to the
So, but the other way would be side, angle, angle.
which doesn't make sense.
All right.
I was going C.
Well, we don't have B marked, so we've got to, right? So, angle, angle, side will do. Okay, so triangle. I'm going to go triangle BDC. Triangle BDC is congruent to what triangle? FDE would work. By angle, angle, side. And then the very last thing, of course, since our triangles are congruent, then ED is congruent to segment CD by?
What?
Was that S in the first one?
C, whatever.
CPCTC. Almost was. Almost.
I'm the winner. Stop it.
All right. Do you have any questions for me?
No.
Okay, fantastic.